Topic is design pattern. So I will be design pattern and design principles. These are two synonyms. And so design pattern basically. So what is pattern generally? If I ask somebody in the team, whenever we are facing some problems in life, we generally tend to see some patterns in that. The same thing happens in the software industry. So we as the developers, when we are kind of developing some products, coding, so we face the similar kind of problems every time. And what happens is, the best brains in the industry, they kind of document all these kind of common recurring problems and the general reusable solutions to those problems, so that other people can follow those patterns to avoid such recurring problems. So that concept of design pattern started from there. So it is like a template which kind of provide the solution to the common problems basically, and it tells how to solve the problem. So it defines the problem, it defines the context of a problem, and then it provides the steps to solve that problem. This is one way of looking at the design patterns. The other way of looking is a documentation of all the best practices. You may say like design patterns are all the best practices that should be followed. If we are designing databases, if we are designing any product, what are the best practices to be followed? Similarly, when one person in the software industry, one developer is talking to another developer and is kind of describing his problem. So these patterns are given the kind of well-defined names, so that each person who is in the development can understand easily what the context of problem is, because the context of problem is very well defined in the design patterns. So if somebody says that I am using a particular pattern, so other developer who is familiar with this pattern will understand it. So that makes the interactions among the developer community easy. But that's the intent of the session today is not to give you much detailed overview on the software patterns, because that require a very deep knowledge of the programming language, and we have a Java session quite late in the series of the classes that we have. The objective is to understand the design principles which are defined in the NDHB and the National Health Stack, those kind of things. So what are design principles? So design principles are the broad guidelines which are provided by the committee members who have written these reports. And generally these guidelines influence the design of IT products to solve the recurring problems of bad design and to achieve a particular goal. So I will explain it, over the course of time, like, how these design principles influence the different products and the product designs. So any question till now? I know it's very vague. Raghav, Akriti.
Very useful. Very useful.
Okay. So are you familiar with any general design pattern in your life? Forget about software. In the common life also we face problems and we kind of make some mental note of those problems. Yeah, these are the problems always happening and this is the way I will solve the problem. So you may say it like a pattern. So it all started with the gang of four design patterns. We call it GOF, and this is primarily for the people who are in software development. So there were overall 23 design patterns provided by the gang of four, and these are useful for the people who are involved in developing the products, softwares. So I am putting only one page on this to explain you, like because Ved covered a lot of things on object-oriented programming and classes, objects, and then he explained about encapsulation, polymorphism, etc. So these are also some sort of design principles. So when to use polymorphism, when to use inheritance. So can some of you tell me like what is polymorphism? This was covered in the day before yesterday class. Anybody? So I think you need to go through the slides, whatever I explained. Okay, so class, class is a template, you all know. Object is a particular instance of that class. This is what Ved explained. So when you are developing a product using object-oriented thing, generally we follow the design patterns in terms of defining the classes and defining the objects and the interactions between the objects. And generally we all the design pattern, they fall in three categories. So one is a creational design pattern is one category, which is related to creation of the objects. So let me take you a very simple example. Singleton is a very common known pattern in the industry. So let us say you want to develop a software and there are certain basic configuration parameters which you need to load at the start of the application, and that should be made available throughout the application. So what will happen if you are creating one object which is containing all the configuration parameter? So would you like to create only one object with all the configuration parameter, or you will like to create multiple objects with the configuration parameter? What do you say, Raghav? Sorry?
Has to be one, right?
Yeah. Why? Because you don't want to duplicate the thing. You only want the set of parameters. And if one object is containing all the parameters, that should be kind of shared across all. There's no need of duplicating that. So singleton pattern explain you how you can create only one instance of an object and how can you ensure that no other second instance be created. Only one instance should remain there. So I'm telling you a very basic thing like, so singleton design pattern tells you the way how you can ensure that only one instance is there. Similarly, the other category is structural design pattern. So structural design pattern tells you about the structures, which are generally like one basic example I tell you is let us say you have the provider system, and I am trying to give you the example from the general common scenarios, not from a software perspective. So if let us say you have a provider system and you want to generate the e-objects from the provider systems. So provider systems has data in all the tables in their database, but you need to model these, you need to model these e-objects using that data. So what is required? You need to kind of connect to the database of that provider system. You need to get the data and you need to create the e-objects out of that. Am I right? So each and every application is a different context, basically. They have a different architecture, they have a different thing. So it is something like you're connected. So you have one program which is generating all the e-objects, and you have another program which is the provider system, HIS or clinical system. And you want to connect the two different systems, or you want to kind of connect these two incompatible systems. Basically, why I'm saying the incompatible is because you're not worrying about the architecture of that provider system. You're not saying that the provider system should have XYZ architecture. It can be anything. You only want to connect to that system, get the data, and use that data to create your e-objects. So creating the e-object part is responsibility of your program. And your job is to connect to any system to get the data. So this, adapter pattern tells you like how you can connect to the different systems and how it allows the different incompatible classes to work together. So you will be creating sort of a common program which will have all the channels and all the connections. And using those channels and connections, you can connect to any system, whatever it is, whether it is developed in client server technology or whether it is developed in mainframe, whether it is developed in entire application or whether it is microservice. You're not worrying about the architecture of that application. So you're not saying that, okay, I can connect only if the system is so and so. It can be anything. You only have the adapters, and using the adapters, you can connect to any system. So adapter design pattern tells you how you can use a common program to connect two different systems. Similarly, you have another program called facade. So generally, we use a common word, Dr. Pankaj and myself, you might have heard several times that we need a facade layer to create the E-objects. So why I'm using the facade layer is because creating the E-objects, you require a lot of, components in that layer. So you need, you need to fetch all the data using the connectors. Then you need to kind of standardize the data. And, after that, you need to do the data transformations. And then you need to model these, data into the FHIR objects. Yesterday, I covered the FHIR. So all these, different complex programs, you are kind of writing one single program, which is containing the interaction of all these components. So that is the layer which is developed on top of the systems. So it is something like that. Okay, I have a system in Fortis. Now I want to use the E-object things, the provider E-objects. So I will use one program which can be developed by the internal team of the Fortis, or which can be developed by any vendor, SCA member, or any outside or government. And I will be kind of plugging that layer with my existing system. Using adapters, it will connect to the system and it will get all the data. And then using this facade layer, I will have all the logic in that facade layer, which will convert the data into E-objects. So facade layer is something, is a very simple program or interface to a more complex underlying objects. So underlying the thing, you can have a lot of complex components which are working together, but the output of that layer would be E-objects, which are sent through the APIs. So structural design patterns are useful in these kind of scenarios. Then the third category is the behavior design pattern. So behavior design pattern is something you learned about the polymorphism. So polymorphism, when Ved explained it, it means the same object can take different forms. So if you have something like draw, a draw method in a particular class. Now, if you want to draw a triangle, or if you want to draw a square, or if you want to draw a circle, you have a different way of drawing it. Now, all of you have studied the geometry. So you might be aware that if you are drawing a circle, you need a radius and you need a center. But if you are drawing the square, you need the, the length of one side, and all the four sides are equal length. So basically, the way of drawing is different. So if there is one class which has a method called draw, and if I give it one object like which want to create a circle, so it should be drawing a circle. If I give it one object to draw a square, so it will draw a square. So that means the algorithm will change at the runtime depending on what you want, what is your intention. But the method is same. Method is same draw. It is depending on the parameters and the bindings, it will draw different things. So if, let us say, you allow the algorithms to be changed on the fly in the runtime, so you have the strategy pattern or the template patterns. Similarly, another example and a very basic example I give is the observer pattern. So again, common life problem I want to give is, so let us say government has a registry. Now, in the registry, if a new thing is added, a new data is added, you want to notify all the systems that this data has been updated so that they can update the same thing in their systems. So you need some kind of a mechanism where the different systems are subscribing to the registry, and whenever there is any updation in the registry, it is notifying the changes to all the subscribers. So it's a publisher subscriber pattern, and we call it observer pattern. So observer pattern, all the programs who want to subscribe to the changes done in one single place, like registry, for example, they will be subscribing to it. And then whenever there is any updation in that registry, it will be notified to all, so that others will be updating based on that. So these are some of the examples, where design pattern comes in. And all these 23 design patterns are explained in from a software development perspective. Gang of 4 design patterns are used. Similarly, from an architecture perspective, Martin Fowler is another well-known person. He has a book, so it has defined over 40 architecture patterns. Similarly, if you want to do the integrations, there are more than 65 patterns, so on and so forth. So I wanted to explain you about these patterns is that in industry, in software industry, there are well-defined guidelines which are available for the software development community to use these guidelines and develop the product in a well-defined fashion. I mean, not in a haphazard manner. So now I will come into the NDHB and National Health Stack perspective. Why they had the need to define the design principle. So they had the similar need to define the design principles there, because unless they define the design principle, the different vendors can have different interpretation of developing the things. So they can develop something, based on their own understanding of the problem. So if you want to crystallize that problem very clearly to, everyone, okay, these should be certain XYZ thing you need to always take care. So these broad guidelines, are published in the form of design principles. And so NDHB provide, a lot of design principles, and before NDHB, National Health Stack document published a lot of design principles. So I'm going to cover that. So before that, any question on this slide? Raghav or anybody?
No, sir.
Sorry?
No, sir. No, sir.
Oh, is it clear?
The last part was a bit tricky, sir. थोड़ा सा उसमें problem. बाकी ऊपर का तो आ गया.
अच्छा, good. So coming back to the point, these are the design principles which we have kind of consolidated from different sources. So some of the design principles are related to the National Digital Blueprint report. Then some of the things are related to federated architecture, what they have described. Then, microservice thing, and then, data privacy and security thing. So we cover it in, one single place. We have kind of classified it. And, I'm going to talk about, some of these things in detail in the current session. Some of the rest of the things will be covered in the subsequent classes. Like, for example, all the microservice related thing, I or Ved will cover, in the session, when that will come. So NDHB talks about certain things. So one primary thing is the registry. And I think yesterday I talked a little bit about registry. So registry are the kind of highly normalized databases. And there is a mandate for everyone to get registered in those databases for some common reason. So if it is like facility registry, then all the registries should be registered in the facility registry before they are operational. And they should provide some minimum data to get registered in the facility registry. If it is a provider registry, then all the doctors who are practicing in the country, they should be registered in some sort of provider registry. If it is a health worker registry, frontline registry, then all the health workers who are in India, they should be registered in a frontline registry. So the objective of this registry is one, you have a common place where you can get the minimum data for that entity. The other thing is it is a source of unique identifier. So each registry generates a common identifier which remain unique across the lifetime of that entity. So if you see the Aadhaar registry, so Aadhaar registry is a very common thing, example, which is there. Already we have a registry, Aadhaar registry. So this UIDAI registry, this one Aadhaar number is generated, which remain constant throughout our lifetime and even beyond that. The same Aadhaar number will not be given to any other. So all these registries, there are certain principles they have defined, and I will be covering that another slide. Like for example, they say like all the registries should have the single source of truth for data. So when we say single source of truth, it does not mean that there should be only one registry or one place. It can be multiple databases, but there should be a way like I can get all the information in a single place. So even if it is a decentralized structure and you have a lot of directories at the respective state level, there should be a way of syncing up the data at a common place, a common registry. Then, mobile first strategy, they talk about that all the applications that need to be designed, we should think the mobile in mind, because there is a lot of penetration of mobile users in the country. Then open standards, So NDHP talks about that, they encourage the use of open standards and, open source things. So it doesn't mean like, they are stopping the other people or the commercial people to do the things. But what they want is, so far so possible, the technology used or the standards used should be in the open domain. And there should not be any vendor lock-in in that. One example is, for example, ICD-10. Now, ICD-10 codes, the WHO has a open source ICD-10 codes, but then US has designed ICD-10 CM, Center for Medicaid. So the ICD-10 CM, which is the US version, it is more refined actually, and it has a lot of billable codes actually. They use it for reimbursements, but then it comes with a license. So it has a vendor lock-in, and it has so basically US has a control on those codes. But government encourages that so far so possible you try to use open source. So it means we should be using ICD-10 WHO for the country, not the ICD-10 CM. So that is the open source thing. Then they says, they emphasize on interoperability, because this everything, what they started the vision of connected government. Yesterday I talked about that. The MITI designed this, India architecture. And India architecture, the basic principle was connected governance. Initially, they thought about the G2C model only, government to customer model. But now they thought, that same can be extended to B2B and B2C as well. So the prime thing is all the entities should be connected. So to connect the things, we need the messaging infrastructure, we need the interoperability thing. So yesterday we covered a little bit about HL7, FHIR. So these are certain ways in which we can do the interoperability. We can exchange the data. Then they talk about minimalistic design with a scale fast approach. So what government emphasizes is they're not saying that you do everything on the day one. We all understand that these are the complex architectures to achieve. It will take some time. But what they say is you should have a scale fast design. And the example is, again, the COVID thing, I want to highlight that today you are using, let us say, one EMR in the system, which can cater to, for example, 500 patients per day. But we all know that, unknown things happen, unnatural things happen like the COVID, and suddenly there is a rush of patients. Now, suddenly one fine day, all the people got panicked that I'm getting the cold and, cough, and I want to get examined in that hospital. And instead of 500, 50,000 people reached in the hospital. So your system should be scalable to handle that sudden increase in load. The demand of, the software services that come to the system, they should be able to handle it. They should not refuse the people simply saying that my system can only handle 200 patients per day. So please, rest of the patient go to other hospital. This way the business will not work. So your system should be able to scale fast. So the other thing they want to say is like patients should have the control on their records. So till now, all the records exist in the respective hospitals. So government emphasizes that, going forward, patients should have a control on their, personal health records, and there should be separate PHR repositories, which are storing all the personal health records basically. So then, PHR has become a very important entity in the whole architecture. And other thing they talks about is the continuum of care. So right now we have the isolated, fragmented, storage of our medical records. One hospital, we have some records. Over our lifetime, we have taken treatment in several places. Now, each place we were registered, we were given some treatment, and we were, some tests were done, all these things. But all those records exist in the databases of those respective hospitals. We do not have a single consolidated record of our lifetime summary. And that is important because a lot of, treatment that doctors do depends on what happened in the past to us. So if somebody, for example, in one episode, doctor recorded that, somebody has a borderline diabetic case. He does not have diabetic, but he's at the borderline. And then next time he's getting a kind of a wound disease or something, like he got a fracture injury. So it's very important to know whether person is diabetic or not. Now that person may not know that that I'm diabetic. He will not tell the doctor. But if doctor has access to his past records, and if he knows that he was a borderline case, then definitely he will like to assess the scenario in that way. So he will like to get some test to confirm whether it's diabetic or not, and then he treat him accordingly. So past records are very important. So these are certain principles which NDHB report talks about. So any questions here, Raghav?
No, sir.
Okay. Sorry?
Sir, all clear, sir.
Okay. Federated architecture, I will cover separately. There's a whole dedicated class to that. But one primary thing I want to tell is there is what NDHB says is there will be concept of data fiduciaries at the local and state levels, and there will be central data lake and EHR and PHR repositories for health data. And as I said, the interoperability layer should be there so that all different provider systems can connect to each other. And all these entities should be uniquely identifiable. So registries are required, and there should be a common meaning of data. So data standardization is required. So all the standards, identifiers are needed. So these are the broad principles which again NDHB has given the guidelines related to federated architecture. Microservice architecture I'm not going to cover today. It is one separate session we will cover. These are all technical related things that we should have open APIs, domain driven design, etc. Privacy and security. Yesterday also we covered certain things that there is already a data protection bill pending in the parliament, somewhere in the Lok Sabha or Rajya Sabha maybe. So what they say is that all the patient data should be secure from three perspectives. One is confidentiality of the data should be ensured. Data should not be accessed by the people who are not authorized or who are not supposed to be authorized to access it. It should be accessible only to the authorized persons. And confidentiality is must. Patient health related information should not be shared across to unauthorized persons. The other thing they say is the tamper proofness of the data. So whenever the data is exchanged from one entity to another, we should be ensuring that while in the transit the data packets should remain tamper proof. Nobody should be hacking that. So a lot of hackers are there, network hackers are there, who can hack the data packets and who can do anything. So tamper proof should remain there. So data packets should remain unaltered. The third thing they say is the non-repudiation. So repudiation word comes from the legal term. So any proof which you can claim in the court of law is a non-repudiable claim. So for example, again, a common life example I want to give. Nowadays, we keep the tenants, landlords, they make a lease with the tenants. It's a 11-month agreement or whatever. And they generally make a notary paper. And this notary paper define all the terms and conditions that, so and so you will pay so much rent and, the rent agreement basically. So government clearly says that any rent agreement, unless it is registered in the registrar office, it cannot be claimed in the court of law. If there is any dispute arising between landlord and the tenant, and on the basis of a rent agreement, which is just notarized, but not registered, you cannot claim anything. So it's a repudiable claim basically. So that can be repudiated, that can be challenged. But if once it is registered, it becomes non-repudiable. Then nobody can challenge those clauses. So that is why registration is a must. Same way, all the data, whoever did the updation, if tomorrow any conflict happens because of the updation, tomorrow doctor can say, no, I did not give this diagnosis. I did not give this treatment. Somebody else might have done. My nurse had the access to my system. She was sitting on the seat. So maybe she might have, inadvertently did this updation. I did not do anything. So there should be a non-repudiation thing. All the data updations, if it are done, in future, nobody should be able to deny that I did not do these updations. So these all non-repudiation, confidentiality and tamper-proofness of data These are the aspects of data privacy and security. And NDHP report clearly talks about all these three things, how these will be handled. And as part of Access Health, we will be kind of working on this piece, like how data security privacy will be managed. Then they talks about control data visibility and consent sharing. So all the data that need to be exchanged from one entity to another, it should be accompanied by a consent document, electronic consent document. And electronic consent document should define the permissions, access level permissions at the storage level, at the query level, and at the streaming level. So how much data can be stored, for what time period it can be stored, who can store it, then who can query it, and then so where it can be streamed, in what mode it can be streamed. So if I have an audio file, video file, or I have something streaming of my data, for how much time it can remain in the cache memory. So all those kind of rules will be defined in the consent document, and it will have the time period as well. So after the expiry of the time period, the the data which was stored, for example, that has to be removed from the cache memory, whatever cache storage. Data provenance is required, like all the changes in the data should be logged somewhere. So audit trails should be maintained. So right now the systems that are designed, most of the system does not have the audit trailing facility. So most of the change, if let us say some developer sitting in the backend can also do updation, and nobody can know who did this change. And when they come to know who did this change, the only thing they can know is that there is a database user password, and all the changes are done by the same database user password. And if there are 50 people in the database team, everybody will say that I do not I have not done this change, because each user has access to the same database user password. So through the audit trail,
give an example to explain that.
Yeah. So basically, what happens is, audit trail should be done at all the levels. First of all, at the application user level as well as at the database user level. The purpose of audit trail is whatever transactions are done, whatever updations are done. So this audit trail record the timestamp, what the change was. So basically, what was the original entry, what was the change entry, what was the timestamp, and who was the user who did the change. So what the example I'm trying to give is, if some doctor has given a diagnosis to the patient, so it should be audit trailed. Okay, this diagnosis transaction was recorded at this time and by this user, which is a doctor user actually. So then a lot of database related updations are also done in the backend today. This is the point I'm trying to raise. So database, administrators, they have access to the complete database, and they can make any query or any updation on the database directly, which is a very kind of wrong thing. So typically, and one example somewhere I faced in past, and I can give you, so I will not name the company, but one example I can give, where there were some wrong values done in the transaction, and wrong values were updated in the system because of some wrong logic developed by a developer, and it was in the production system. So then what was done is, the developer from the backend actually kind of issued an update command on the table directly, and he changed the value. Now the issue happened is that one print report was generated, one report was already generated which had the wrong value, and based on that some conflict arose in the hospital. And later on, this developer changed the value from the backend, and when again the report was reprinted, then there were certain other values. Now this raised a lot of conflict. How did this value change? Doctor said I did not make any change, and all the medical staff said that we did not this change. So, and we had no mechanism to know who did this change, because whatever database logs are there, it has only database user password. So individual users were not given the individual user IDs and the passwords. So there were no proper audit trails maintained. So then everybody was asked who did the change, and everybody said that I did not make the change. So these kind of scenarios happen in practical life, and this happens in the financial world as well. So unless we are maintaining the audit log of who is changing, when is changing, and what is changed, we cannot track the changes. So data provenance requires the maintenance of audit trailing, to ensure the kind of trail of changes basically. One more thing is, in medical domain, hard deletes are never recommended. So can anyone tell me like what is hard delete and soft delete? Raghav, you have some idea?
No, sir.
Okay. So you learned about database class. Ved covered the delete command. So basically this delete command, we can delete anything in the database, in any table. So generally in medical domain, we never encourage a hard deletion. So hard deletion means you are permanently deleting the value from the table. So instead of hard deletion, what we say is there should be a provision of soft delete. And soft delete means that if you want to kind of deactivate a record for some reason, it's a wrong entry or kind of it is expired, then you should not delete the entry from the table. You should keep a flag in the same record, and you just make the flag off. So for example, you have a flag which maintains the active or inactive status of the record. So you just make the status inactive, and you just record the date when the this status was changed. But your record should not be removed from the database. So that is called soft delete. So this means, all the changes done in the database should remain there. At any point of time, if I want to see the trail, what were the changes done, I can see that. So still, lot of products, there are very few products in the provider space which follow the audit trailing and the soft deletion policy rigorously. So these are the kind of things which come in the data provenance thing. And then the rest of the things in security are all related to different levels of security. So yesterday we covered the OSI model. If you remember, I covered the 7 layers. So basically the bottom layers are all data link layer, for example, physical layer, data layer, sessions. Then on top of that we have transport layer. Then we have session layer, and then we have application layer. So generally we can implement the security up to 7 levels. So there is a level 7, up to level 7 we can do the security, but normally it is recommended that up to transport layer we should maintain the security, which is level 4. So level 3 or level 4 we should maintain the security, which is all the network devices which are involved in the transmission layer. We should maintain the security of all those devices. We should maintain the security of the network also. So I think Ved will cover that in the network part. Like for example, we have the VPN or we have the MPLS. In Max Healthcare, we followed the MPLS cloud. So all those networks have the provision of security. Then, so up to the network device level, up to the network level, then at the application level, we should ensure the security of the data packets. So which can be done by, for example, the encryption things, the SSL. So we have the HTTPS. You might have seen, a lot of, websites are running on HTTPS, which is a secure link. Then, we have the ways like digital signatures. So these are the different ways we can ensure the data packets are not tampered when these are exchanged. So what level of security should be maintained? Up to now, it was open question to the architects, but now clearly this data security provision says that up to 3 or 4 level security should be maintained. So any question on that?
So could you please repudiation again with another example maybe?
Okay. So repudiation, again, one example is in case of registry. So registries are very clearly defined as the single source of truth of data and a non-repudiable version of data. So whenever any changes in the registry are done, so for example, Aadhaar. So Aadhaar, we can update our mobile number or, whatever, address or something. So updations are possible, but each updation is recorded with the, digital. So basically each updation should be authenticated. And there are different provisions of authenticating that. So one way is, the user who are allowed to do the updations, they have the digital signatures, and their digital signatures are authenticated before they are allowed to make the changes. And these are recorded somewhere in the log. Okay, this is a user who did the change. So the audit trails are maintained. So if you have digital signatures, you have audit trails, and you have the authentication of the updation APIs, then the user who has made the change, tomorrow if he challenges that I did not make the change, he cannot challenge it. This can be taken to the court of law. And this can be proved on paper with evidence. Okay, this was the digital signature used in the transaction. This was the authentication done. In the authentication, this was the user ID. And this is the audit trail. This change was done at this timestamp by this user. And this was the change. So based on these evidences, the non-repudiation claim will be non-repudiated. It can be challenged basically. So repudiation word has a context in terms of legal context. So any changes done in databases like registries should be non-repudiable, non-challengeable.
Sure.
Krishan, one more thing that needs to be brought out is in the courts in India, it has been said that electronic medical records, so in terms of medical records, so they can be stored as electronic medical records as long as it is safely stored, safely retrieved, and it has an electronic signature to validate the records, right? So now if you look at most of the HIS systems in India, they do not they're unable to satisfy any of the three requirements. So from a legal standpoint, none of the HIS in India will be able to stand in the court of law from a EMR perspective. So that is the reason, because they do not follow all these, privacy and security and the design principles that are being talked about here. As a result, they're not legally viable. So repudiation. So that's the point in terms of repudiation.
Yeah, absolutely true, sir. And also, so basically again in the signature thing, government had a plan to use the e-sign. So generally in MIT they use the e-sign for all the signatures. But now they want to take it to the next level in the health domain, and they want to use the digital signatures. So digital signature, maybe I will cover it in another session. It is a pair of cryptographic keys. Okay. And this is not just a wet signature. It's not just an electronic signature. This is a digital cryptographic pair of keys using which we can sign the data whenever we are exchanging it with any HIS system or EMR system, whatever. Mm-hmm. So, and that record will be maintained basically. Like whatever validations are done using the cryptographic keys, that record will be maintained. So it will ensure the confidentiality, it will ensure the tamper-proofness. So all these things will be maintained. So you are absolutely right that today this aspect was almost ignored, in all the HIS systems. But now after NDHM, this has become an important thing. So in the data privacy and security, this aspect is clearly highlighted, and that will be required.
Yeah, and in medical legal cases, I have been invited as an auditor, and there are people who have gone to jail after my statement.
So when we say the compliance by standardization testing and quality certification by STQC, so it is not just the testing of functional scenarios, it is a testing of all these design principles in place. So if there is any new product design, so whether it has a provision of all the data security, privacy thing, repudiation thing, controls, and then all things that we are talking about. And if the minimum things are there, only then the product is certifiable. Otherwise not. Functionality wise, it is still open to the people because we cannot kind of standardize the health domain per se. The health practice is still it will take a lot of time before we standardize the whole health practice. And technically we cannot solve it. So what we can do is our design principle should be followed rigorously and sacrosanct way in all the systems. So now each of the remaining slides, I will talk in little more detail what are these design principles, and some of the things I've already spoken with. So when we say that registries, so for example, the drug registry that we require or any new registry, disease registry that will come, there are certain design principles which have been highlighted in the National Health Stack document, which is a precursor of the current NDHP report. So they say like, all the registries should be self-maintainable. So by the term self-maintainable, it means all the entities which are listed in registries should be able to view their information and should be able to update their information through workflows in trusted and verifiable manner. So if I break down this statement, so a lot of things come in. So one is all the entities who are accessing the registries should be listed in the registries, number one. So there should be a user authorization, user authentication and authorization process. So no unauthorized entity should be able to access the registry. Second thing is who will be able to view and who will be able to update. Those authorization rights should be clearly defined in the registry. So there may be certain entity who can only view the information, and there might be certain other entities who can update the information. So for example, there is a central registry, health worker registry. Now we say like there are different applications who can send the data to the health worker registry, and that health worker data, after some algorithm, verification algorithm can be used to populate the registry or update the registry. There will be some APIs for that. So that kind of privileges will be well defined. Who can update, who can read. Now, whoever can update, they're clearly saying the updation of information should happen through a workflow. So there should be a workflow process. Even in the Aadhaar registry, there is a workflow used. It's a maker checker functionality kind of thing. So all the changes, let us say if I have updation API and I make a updation in one particular record in say Aadhaar, for example. So that updation will not directly happen in the main database. It will happen in a staging database with some status. For example, the initial status is draft or maybe kind of require approval. Then there will be another set of entities or another group of users who will be validating that record. So whether all the supporting, so you might have seen in the Aadhaar website, if you want to make an address change, there are some supporting documents are required to be attached in the website, or maybe it need to be given to the center, Aadhaar center. So all those supporting documents will be validated and verified, whether these are correct, and all the information is correct and all. And then on that basis, the reviewer will kind of approve that change. And only after the approval, that updation will happen in the main Aadhaar registry database. So there is a workflow associated with that. So it's like a radiologist workflow. Junior radiologist write the report, senior radiologist finalize the report and put the signature. And all the changes at each stage will be kind of digitally signed. So tomorrow the reviewer cannot repudiate his claim that I did not review it. Somebody else might have done. So if there is any conflict happening at anywhere, this can be solved. I mean, this can be tracked. So these are the certain principles. And one more thing they are saying is that updation of information should happen in a trusted and verifiable manner. So all the things, what we have spoken related to data security and privacy should be followed. So these are some minimum things they spoke about the registry thing. So we cannot make any database and we cannot put anything and we say like this is registry. These are the things which are required to have there. So we should have a user access management. We should have a workflow for updation. We should have data non-repudiation controls. We should have, the security, privacy, encryption features, all sort of that thing. And the second part we have already covered, which is non-repudiable data, that source of each attribute in the registry should be visible and all attributes digitally signed by the authorized updater. So this part we have already covered. Like it is possible that in the whole record, one attribute might be changed, by one user, the other attribute might have been changed by other user. For example, this Aadhaar example. Now, Aadhaar example, I got my Aadhaar record created by somewhere. Initially, I got in Delhi center. I gave all my documents. My Aadhaar was generated. Then, I was in Bangalore and, I need to change my mobile number. So there is another user sitting at the Bangalore center where I will put my request to change the mobile number. Then, somewhere, I go back to some other state and there I need to change my address. So the third user will be kind of changing the address. So address, mobile number, all these are different attributes of the same record, but the different users are updating it. So each source of attribute should be visible in the audit trail basically. And then each updation should be digitally signed. And again, the audit trail should be maintained and all sort of that thing. So these are the basic minimum provisions in the Aadhaar updation. And same will happen to all the registries. If it is a doctor registry we are talking about, and if there is any change in the certificates, some certification of the doctor is upgraded, so then he will kind of either update it using mobile, or he will go to some place and center or somewhere, he will give his documents, certificate documents. So all those updations, where it came from, who did it, all those things will be clearly tracked, logged in, and digitally signed, so that non-repudiation of data can happen. The third thing they talk about is the incentive aligned design. So as I said yesterday, that registry is not registry unless a mandate thing is there. Otherwise, it's a simple database. So technology level, it's all database with certain more features. But the very common thing which is differentiating registry database from rest of the databases is mandate, regulations, those things. So there should be a mandate for all the entities to register their data in registries, whether it is incentive aligned mandate or whether it is compulsory mandate, that depends. So if it is a facility registry, then maybe in our establishment law, clinical establishment law, or somewhere there should be a provision that all the facilities operational in the country has to be mandatorily registered in the facility registry. Otherwise, what will happen? Nobody will bother to get the registered in the facility registry. Same way, all the doctors, some mandate should be required that all the doctors practicing in the country, be they the Ayush doctors or be they the allopathic doctors, they have to be mandatorily registered in the provider registry. So mandate component is must. One another example is the payer thing. So if we are talking about a payer registry, so all the TPAs and all the payers are mandatory required, to be registered in the payer registry. So if, for example, there is a hospital empanelment data, now hospital empanelment data, if there is a payer registry where all the hospital empanelment data is maintained, for example. So one way is, hospital can directly send the data to the payer, and payer may update the payer registry with that data or may not update the registry with that data. So unless the mandate is there by IRDA, it is quite possible that hospital will directly send the data to TPA or payer, because this is what they have been doing now. So once the payer registry comes in, and if NHS says that I want all the empanelment data to be sent as the e-facility info object to SCP, then it is a mandate. And then, this become a registry, payer registry. So no hospital can directly send the data to payer. They have to send it through the registry. So those kind of things are required. Then other thing they talk about is extensible and flexible schema. So we all know that, we have given a minimum viable design of registry. But it is quite possible that whatever we have given in the minimum viable design, there may be a need of adding more elements in that. Or it is also quite possible that in future we may need to update more things. So if you see the Aadhaar registry, today they have 5 or 6 data elements, which they are updating in the main database. But in future, they may need to add, 1 or 2 more, depending on the requirement. So we have kind of a data of, more than 135, million people in that. So making change in the existing database, adding any data, attribute and, then re-indexing the data, I think Ved Prakash can tell you easily what the overhead will be. If you have a data of the size of 135 million population. So what they say is technically there should be a way of extending the schema in such a manner that it is not impacting the operations of the registry. So there are different database ways of doing it. You have the materialized views, you have the ways of updating the views. So basically all the access is to the data is happening through the views rather than main database. And you have a flexibility in the schema. So you have designed the schema in a manner that you can add more fields in that without kind of re-indexing the data. So one example is you have an entity attribute model. You can follow, but this is a little bit more technical, so I will not cover much detail here, but there are certain database ways to ensure the flexible schema thing. If I will just go and add one field in the database, if 100 users are using it, okay, I can take a downtime and I can do it. If it is an Aadhaar-like registry, making change of one single element in the database and re-indexing the data, it will be a nightmare. So we have to ensure the such controls are maintained so that in future, if you need to change the schema, you can easily change that. So one way is you can have the derived views rather than using the main view. And you can use derived views to access the data so that, you know, any change in the schema is not impacting your existing data usage. Any questions on that?
No.
So I'm trying to tell you more, you know, from a perspective that when we are saying we are designing a registry, we need to ensure that all these controls are somewhere defined. Because these have been clearly laid out in the documents, and the team, or, you know, the team of experts who will be kind of evaluating our design, they will be validating it against these parameters. Then open API, we all know that, you know, whatever create, retrieve, or update or deletion operations are required on the registry, that should happen through open APIs. And in all these APIs, there should be a provision of entity authentication for data security. So there are a lot of ways, you know, doing it, token-based security, or, you know, OAuth or those kind of things. Then control data visibility and consented sharing. This I have already covered. Even in the registry database, we should have a way of marking, like certain attributes are public attributes which can be visible to the public. Certain attributes can be there in the registry which will be in the registry but not visible to the user. For example, in the health worker database, for example, the employment status and the performance of the health worker. If you want to maintain those kind of parameter, maybe you will not like to make it visible to health worker directly. You will like to make it visible to their supervisors only, for example. So that kind of control at the attribute level is required. What should be visible, what should not be visible. Certain thing you may need to mask or encrypt if it is containing any sensitive data. If there is a disease registry, for example, in future. So if we are recording all sort of diseases, we may like to mask certain things so that it is accessible only to the authorized users. The disease related information cannot be shown to anyone. So those things are required, and data provenance I've already covered, which is audit trail thing. So these are the necessary characteristics and the design principles for registry design. Raghav, any question on that?
Sir, how will we ensure that everything is covered in the registry? Like when we say that we'll have a drug registry or something, how will we know that all the drugs in the country are covered, and are they validated or not? How will we make sure?
This is a little tricky question. I think answer to that Dr. Pankaj should give. But, you know, I can only say, like, you know, so let me give you the CDAC example. Today, CDAC has published the drug extension codes, but, you know, they have not published it for all the programs. They have covered only 3 programs. So they have provided the generic drugs for 3 programs. And, you know, as and, you know, when more programs will be notified, they will be covering it. So one approach is like this, incremental approach. So you may identify initially the sources of the drug codes which are there in the country, and you can first populate all the drug, you know, related information from those sources. Going on, so this is the first starting point, which is the base version. And then on top of that, if you feel that more sources would be required to be added in that, there should be a way of updating the registry. And, you know, so one is the mandate thing is required. So you need to mandate all the entities which are involved in the drug thing, who are maintaining the drug databases. you need to mandate all those entities to participate in the registry. And they need to register and they need to, kind of populate their data there. Second thing is you need to identify the core entities initially and put a base version of the registry, which is a minimum viable version. But you should have a provision of updating the registry so that tomorrow new drug programs come in, extensions come in, or new entities are identified, then you should be a way of registering them and getting their data. So this is the technical answer I can give, but I leave it to Dr. Pankaj and you and everyone, because you have worked on drug registry. So you may tell me more better, like how you will like to populate the drug registry.
So, I mean, the incentive aligned design is the answer. Then, there has to be a mandate or there has to be a regulation which will make it mandatory for every concerned entity to put the data in.
Yes, that is right.
That's the key. Really.
Yeah, I think the question Raghav was asking is how will we ensure that all the data has come?
If there's a legal provision that says that you got to put your data in, otherwise you have certain incentives or disincentives, then people will put the data in.
No, but even before that, have we identified all the entities who are supposed to be registered in the drug registry for the source of data? So be it all pharmaceuticals or drug controllers.
Yeah, so if you have a system of disincentives saying that if you don't register, there is a consequence to it, then people will register. Of course, it's a period of time that it will take. Yeah, but it's a good question, and compliance is always a question, right?
Yeah. So the other very important aspect that NDHP talks about is the cloud first strategy. They have a mobile first strategy and they have a cloud first strategy. So cloud first strategy, what we mean by cloud first strategy, I will like to cover some time on this part, because we all are talking about cloud first thing. So we should be aware of that. So basically, if you see today's scenario, almost all hospital CIOs knows that OPEX model is much economical for them rather than CapEx model. Now there is some old generation who want to maintain their own data centers, own IT team, and kind of servers maintained in their IT rooms and all, but these are all legacies. The latest trend is basically to kind of make their budgets economical and maintenance more manageable. They want to kind of host their systems on clouds, because they have some better advantages of hosting on the cloud. So one is definitely that they don't need to procure the space, they don't need to make the data center, so they can avoid a lot of capital cost in that. The other thing is a lot of features related to replication of data or kind of scaling thing that is already provided by the cloud. So they did not to worry about those things. So almost all the hospital CIOs today know that, okay, we can host our database on cloud. It's a cloud application. But to be honest, fairly honest, I would say cloud hosted application and cloud enabled applications are two different things. I can host any application, even a client server application I can host on cloud. I can host the server on cloud and I can provide the access to all the clients through this internet IP. That is possible. But it is a cloud hosted application. So I have not taken the space in my data center. I have just put the server on the cloud. That's all. But this is not cloud first strategy. When we say cloud first strategy, it should be cloud enabled application. And when we say cloud enabled application, it should be leveraging the cloud services properly. So one of the cloud service thing is it should be auto scalable, because we all know that cloud provides the elasticity. So when we say elasticity, it means let us say I'm today starting with a certain size. So I have created a virtual machine on cloud. So I have taken a certain CPUs, I have taken a certain storage in Azure, or maybe I've started with a free version. Now what they say is pay as you use. Most of the clouds are providing this model. So as much resources I'm consuming, they will be generating the bill based on my actual uses. rather than, what I have initially provisioned and, I'm getting a constant bill for that. So the advantage of this is, depending on the load and demand on my system and the resource usage, my actual bill will be generated. So it is a elastic demand model. Sometimes if it is, scaled up, a lot of, requests are coming, my system is overused or kind of highly used, then my bill will be high because I'm kind of overusing the system resources. So when I'm saying resources, it is CPU, it's memory, it's database, storage, all these things, or even the IP addresses and all. If let us say sometime, some months, people are all hale and hearty, nobody has come in the hospital, the resource demand is very low, so I will get a lesser bill. But to be honest, all the applications which are just hosted on the cloud, what they does is they create a VM. So they identify a certain size of the VM and they keep paying a monthly bill for that size, irrespective of whether they get 100 people demand per day, 100 patient demand, or they get 1,000 patient demand per day. Their bill will remain same. If they start getting more demand, then they will increase the VM size. They will add, more VMs, or they will increase the CPUs, or they will increase the memory. So this is the traditional way of handling the things in cloud data center. Almost all the IT teams today in hospitals are doing this thing. But what NDHB says is you should have a cloud first strategy. So you should design the applications with a basic design principle in mind, which is minimalistic design, but scale fast approach. So you start with little small thing, but it should be able to scale fast. So scalability is a prime, important, factor which they have, attributed to. And to make any application cloud-enabled application, there are certain patterns available to that. And these are all called, are the cloud patterns basically. So one of the thing is basically, for example, the external configuration pattern. So today what happens is, we all know that, whenever our application start, we say the boot up of the application. A lot of, configuration things are required, parameters are required. So this currently what happens is our application itself contain, this configuration thing. So if I want to scale up automatically, it means whenever the load is increasing, one new VM is automatically kind of created, or maybe a cluster, a Docker image or whatever, it is automatically, booted up, and it somewhere it read the configuration from a file which is external to the application deployment, and based on the configuration parameter, it boot up the application. So it start the application automatically. If we have some such kind of thing, then if my load is increasing, today I have, let us say, 2 Dockers or kind of 2 containers which are hosting my application, but suddenly demand has come because of COVID and I want 10 containers. So cloud will automatically scale up. You need not to worry. It will create 10 images and it will host the application image files. So basically Docker image itself will contain the application thing, and then it will read the configuration from an external file and it will boot up the applications. Your application will run. And when the load has become less, so it will scale down. So it is the auto scaled function. But it can happen only when your configurations are external to the application deployment. So in microservice architecture, when we are teaching the SCA members, we are telling them that we should have a cloud config model. So your configuration should be somewhere stored in the Git files or maybe some external files, so that application can read those properties and based on that it can boot up externally. So this is the first very important design principle of the cloud, which is not happening in the current applications. Any question here? Raghav is a little bit technical, I know. Raghav or anybody? Hello. I'm not able to read. Your voice is very low. Sorry.
No question, sir.
Okay. The other cloud pattern is cache aside pattern. So generally, okay, so we all know that whenever we are reading some data from the application or writing some data from to the application, we are kind of hitting the database. And one thing we all should know is, out of all the resources, database is the most, contentious resource. Basically, the read and write, input and output operations, I/O, we call it I/O basically. The I/O load on database will decide the performance of the application. And this is a one single critical path in the entire thing. I can scale up my multiple application, virtual boxes. I can create multiple application servers. I can do many things. I cannot have multiple databases. I cannot have multiple write databases. So, and even if I'm doing a multiple active kind of thing, it is very challenging and very few applications are doing that. So generally what we do is, if we want to kind of make our read faster, so we generally create a cache layer in the memory itself rather than database. And we load the data from the database in a regular interval into the cache memory. So cache memory is your actually RAM. So what we do, we provision for a increased RAM. Are you aware of RAM memory, Raghu?
Yes, sir. Yes, sir.
You all know that your laptop has 8 GB RAM or something. So generally, a very simple thing you remember that it's always faster to read something from RAM memory rather than the disk memory, disk storage. Because if you're reading something from the disk storage, it takes twice or thrice more, overheads than reading something from your memory thing. It's always faster for reading the memory. So imagine if, let us say you have the static data, or you have your master data, or you have the data which is not very frequently changing. If those kind of data, if you populate that in the cache memory and read from there, rather than database, your application performance will be much faster. But in order to do that, you need to implement certain things. So we have kind of a lot of caching layers are there. So Redis is one, Memcache is another, and clouds like AWS, Azure, they all provide Redis. They all provide the Redis services basically, if we want to use the cache layer. So what happens is, one of the concepts you need to remember is a cache hit or miss. So it means like each and every read of the data, we should first look into the cache memory. If it is not in the cache memory, then I should look the database. That is the first thing. So if something I will find in the cache, I will use it. So I will be avoiding the hitting the database, because as I said, reading and writing in database is much, it requires more overheads rather than reading something from cache. The other thing you need to remember is, whenever you have a cache, there are always the chances that you are updating something in database, but that thing is not reflected in your cache. Then your cache will have still the older version of data. So you should have a mechanism of refreshing your cache with your database changes. So whenever you are updating something in the database, it should be invalidating the entry in the cache memory so that your cache can be refreshed. So one of the principle is, if you not find something in the cache, you should be reading the database and populating your cache. Second thing is, you should have an expiry time where your cache get expired after every 10 minutes or every 1 hour, and it refresh the data. Third thing is, if you update something in database, it also update in the cache. So if you follow these patterns, then your cache will also always be up to date with the database. And if you have kind of constant data, or which is not very frequently changing. So for example, if I have kind of a scenario where I want to read the last 2 visit records of the patient, or the last visit record of the patient always, to get something in the current transaction. This is just a hypothetical example. Now the last visit record, that visit has already closed, so you're not updating anything in that visit. So what is the point of reading it from database? You always populate the last visit or last 2 visit data into cache and read from there. So the advantage will be that you're reading from the memory. So one is your database read-write operations will be saved. The other is your performance will be faster. So this is one example, for example.
Okay, so while Krishan comes back, any questions I can answer or any help I can sort of do, help you understand the concepts that Krishan was teaching?
Sir, just that question only. If we can't mandate things as of now, so the registries will not be formed or made.
So registries can be made, but as Krishan was saying that it has to be a single source of truth. For it to be a single source of truth, the data needs to come in from all the stakeholders, and all the stakeholders need to access the data from that single source of truth. If the single source of truth cannot be established, then the very purpose is lost.
Okay.
So, it is like this, that in a legal document, if you put one dot extra, the validity of the document is lost.
Yes, sir. Yes, sir. Like an extra comma or something.
Yeah. You put one little thing extra and the validity is lost. It's the same thing with the registry. It's like very similar to when you go to a temple that, priest makes you follow a certain procedures. And, priest is so particular that, you do one thing wrong and everything sort of, so that it's the same thing, that you have to respect the sanctum sanctorum, the sanctity of the registry. If you do not respect the sanctity of the registry, then the very purpose is lost.
So then I have one question though. All the extensions which CDAC has provided for the 3 programs, right? So they have been validated by whom?
So has CDAC put together a registry yet?
No, I don't think they have put together a registry, but they have, I guess, they've enlisted certain extensions. That's it.
So you gave your answer yourselves.
So can we use that?
Until it is a registry, there is no sanctity to it. And so to make it a registry, there is a process to be followed. In India, there are very few registries. India as a country is yet to sort of understand that concept of an electronic registry. For example, Aadhaar is a registry. So for Aadhaar, all the sanctity is very strictly enforced and maintained.
Yes.
Yeah. And then there are a couple of more examples in the telecom world. There are examples. So there are registries. So every user, when you get a SIM card, so every SIM card is registered. There's a non-reputable registry of all SIM cards in this country.
Yes,
each SIM card has a unique number and it is listed somewhere so there's a process to be followed. So you lose a SIM card, you have to go back to them with your IDs and everything else, and only then they are able to generate a new SIM card. So when they generate a new SIM card, basically what they're doing is they're generating a new number and tagging it to your ID. So, Krishan was talking about soft delete and, hard delete, right? So yes, this is exactly the point. When you lose a SIM card, what they do is they do a soft delete and they tag a new one to your ID. But actually that SIM card, the one that you lost, is never deleted from the registry.
Yes, sir.
Similarly, in the finance world, you may go to an account number and close your account. But from the registry, that account still exists. It's a soft delete that is done. It's not a hard delete. The account never goes away.
So, but these days, like for the SIM card, our previous number, if it is non-usable for a while, they are given to a new user. So
yeah, number. You have to distinguish between a number and a SIM card.
Oh, okay.
So the phone number is only an attribute. The SIM card has a unique ID.
Okay.
Yeah. So I think Krishna is back. Krishna, are you there? No, we can still hear him. Okay. So while he is trying to fix that, any other things I can help you?
Can you hear me now?
Yes, we can hear you. So I was trying to be the filler while you were gone.
Okay. Yeah, sure.
But they have some specific questions about the sanctity of a registry and legality of how do you make sure that the data is credible and everybody respects it, sort of a thing.
Yeah, so one of the thing is, there is always some set of validation rules which are applicable before you are populating the registry database. So those validation rules need to be passed. And as I said, like updation in the registry cannot be a straightforward, thing. It has to follow a workflow. So maybe the first thing is like you're making a draft change in the registry, then it passes the validation stage. Then after that, it comes to the reviewer point where they review the changes and then they allow the updation in the registry. Now, this entire thing can be done by a human team, or that can again be automated. So there are a lot of workflow engines available. So this can automate the entire process. So finally, based on this validation and the review, you can ensure that all the data is correctly populated. And then there will be certain technical controls in place, database controls in place. A lot of constraints will be defined in the database also. Like if this mandatory attribute is missing, then it will not allow the data to populate. So they will define the mandatoriness of the attribute, and the non-mandatoriness of the attribute or the default values, and all these things will be defined at the database level as well. So collectively, all these controls will ensure that whatever data is populated in the registry is kind of clean data. You're not entering any junk in that. And each and every registry, the validation rules are kind of different. Basically.
Yeah. So Krishan, while you were gone, I gave them 3 examples of registries. One was the Aadhaar as a registry. Second one is in the telecom world, the SIM cards have a master registry. And the third one is all the bank accounts, there is a master registry.
Yeah. These are all, great examples of registries. And these are the only registries I would say available today. Telecom as a registry, as you said, Aadhaar is well-known registry. In fact, it is one of the largest registry in the world. So should we start now? So the other cloud patterns I want to highlight is one is a federated identity pattern, in which case you have an external IAM, identity and access management software, which is managing all the authentications basically. So generally what it says is it is primarily used in the scenarios where you want to do the auto single sign things, or you want to actually develop a suite of SaaS applications. Sometimes like you have developed the different small applications and you want to kind of federate all those applications together. So if user has logged in one application and if he's signed in one place, it doesn't require the signing in every time he's accessing the other application. And I think in our previous organizations, for example, in Dell, I can give you the example. So whatever HR application there was, so it has a Dell portal for all the employees. And then from there, it had the link to the HR portal, for example. So HR portal application was a different application, but it was connected through the same main portal. So if I have logged myself in the main portal, I don't require again logging in the other application, so HR application, sorry. So it will be directly accessed from there. So we call this process as single sign-on. So wherever you have a requirement of single sign-on, that you need to sign on only at one time. And then all other applications which are part of this federated group will be auto-logged in. Or if you require the software services which are kind of providing this services as a common pool, then you need this kind of pattern. Now, one of the scenario can be like if we are talking about health worker registry, for example. So there is a main registry and there will be several directories which will be maintained by state levels. For example, there is an employment directory which will be maintained by the respective states. And at a central place, there will be a central registry. Now, if we are making a portal application to access the main registry, for example, and simultaneously, if I want to see the employment record of that health worker, so I need to access the employment related application of that respective state. So if I am not following this pattern, then I need to log in 2 times. One, I will log in the main portal to the health worker registry to do certain data changes or viewing the data. Then if I need to access the employment record, then I need to log in again in the employment related application of that state. But if I follow this pattern, then single sign-on will happen. And so what I need to do is basically what we need to do is all the state level directories and their respective applications, we need to bring, as part of the federated identity group. And then all these applications will be working closely as part of the single sign-in group. So that example will be useful in that scenario. Then we have a gatekeeper pattern. All the cloud application that we are designing, we should have a gatekeeper pattern. So gatekeeper pattern, generally what we do is a dedicated instance which acts as a broker between the client and the services. So in the microservice architecture, we have the API gateway. So this API gateway, we will cover more in the microservice class. This API gateway is the first layer where all my requests from the clients are landing at. And then at the API gateway level, I can apply my security related controls. I can validate and sanitize the request. And then, I can route these requests to the respective modules, which can be different microservices or which can be, different applications or whatever. So this gatekeeper, the advantage is basically is kind of acting as an insulated layer between the main applications and the client. And generally, if you're not even if you're not following a microservice architecture per se, even then we require a gatekeeper kind of thing for the normal applications in the cloud, because we should not directly hit the server. We should have a dedicated host sitting somewhere in between, which has the additional security layer so that it limits the attack surface of the system. So we have a term in technology called attack surface. So how many places I can attack my application? If I have a larger attack surface, it means my application is more prone to security risk. So I can hit it anywhere. So the kind of intent of the design pattern is to minimize the attack surface so that I ensure the enough controls, implemented before reaching my server, which is containing the sensitive data. So this gatekeeper pattern is one in that. So in microservice architecture, API gateway can play the gatekeeper. Then we have another pattern called circuit breaker pattern. So all these cloud applications, it is very important to handle the faults and failures in a respected manner. So when I'm saying respected manner, it means if in the case of microservices, if one microservice fails, my other services should keep running. It should not bring down the entire system down. Or it should take me to one page where, it tells me like, okay, one particular thing is not running, but rest of the things you can access or whatever. So this circuit breaker, ensure that thing. And again, we will talk more about it, in the microservice thing. And then Open API model, we are all, talking about Open API, and we will tell you about API in a separate session again. So these are all the common patterns. These are some of the patterns. I'm not saying these are all the patterns basically, but these are some of the patterns which are required in the cloud first, applications. And all the new applications that are built by our SCA members or whether the entire community, they should follow these patterns. Right now, if you see all the current monolithic systems, very few of these patterns are followed, or maybe none of these are followed. So if somebody claims that, I have hosted something on cloud, I am a cloud application, the answer is simply no. They are only cloud hosted application. They are not cloud enabled application. And the intent and the design principle of NDHP report is cloud first, which means cloud enabled application, so that you can scale up or scale down, automatically depending on the loads. Scale fast is the main strategy they have. The other thing, NDHP talks about is the mobile first strategy. Now, again, there are different connotations of using this word, but the main intention is basically there was a survey done by International Data Corp in 2020. And as per them, there are 450 million smartphone users in the country. But same time, there are around 550 million feature phones. Sorry, it is feature phone. I've written smartphone. So when we say feature phone, it is less than 1,000 rupees cost, like Samsung Guru, for example. So most of the people are carrying these kind of mobiles. So if you see the data, then 450 million are smartphone, but 550 million are feature phones. So whenever we are saying mobile first strategy, one of the things we are saying is we should be able to deliver the data and content on multiple platforms, starting from mobile. So we should think the design in a mobile way. And when we are saying mobile way, the mobile screen is not, as big, or is not containing as much data as you see on the browser. It is containing only the limited data, and there should be a proper UX design principle should be followed in that, so that your number of clicks are low. You can see the maximum contextual data on a single screen. So those kind of basic principles need to be applied, because designing mobile application is not easy thing. Technically it is easy, but user interface is more important, because you can see only limited data on a particular mobile screen. Then you should, so basically whatever application you are designing, you should first consider mobile in mind, because the payload, the data requirement is very low on the screen. You need to show very limited data, but very contextual, highly contextual data. And you should be able to, kind of deliver the data and view it on multiple platforms along with mobile. So you can see it on browser, you can see it on, you can access the data through IoT also. So multiple platforms you should be able to deliver the data and content. And that is why the fifth layer in the NDHP technical diagram that I was showing was access and delivery thing. And this is very important. So from health worker perspective, it is more important, from government point of view, because all the health workers, they want to give the application access to all the health workers through mobile. But one thing so in our architecture, what we are kind of proposing is API gateway. So it mediates all the requests and responses, and it can deliver different payloads to different media platforms. So if we want to deliver the media, maybe you mean the response to the web browser, it can contain the whole lot of data there. But if you want to deliver the data to a mobile, you need to contain the size of packet. Considering the bandwidth issues, it is even more important, because the larger your data packet will be, on the low bandwidth, your application will be much slow. So one of the things we need to carry in mind is, and yesterday also I said, is whenever we are designing any mobile application, so most of the people think that the users will have a smartphone and they want to bring all the best features of the mobile phone. That you have a SQLite database, you have accelerometer, you have this thing, you have that thing, all the features available in smartphone, and they consider that in designing the application. But as you can see, there are 550 million feature phone users in India. So again, we need to think of different versions in that. We should have the simplistic application design, which cater to feature phones as well.
By the way, feature phones are still growing at 27%.
Yeah. So all the mobile applications today, if you see, how many are running on feature phones? I think none.
Yeah, nothing. It's a very elitist thing at the moment.
So that is the thought process we need to do. And then one of the things we need to consider is the online-offline architecture. So whenever we are designing a mobile application, we cannot just imagine that your server is always online available. Because I am, carrying my mobile phone, I'm walking from point to point, and you all know that it's a tower-based mobile coverage. Some place my signals are very good, other place my signal get down. I sit in, inside the metro, then my signal goes off. Then I come out of the metro, it become again strong. So mobile signal strength is variable. So considering that, you cannot just design an online application architecture for mobile. You have to design an online and offline architecture both. And whatever crucial, so for example, a health worker, if we have designed a health app, mobile app for health worker, which is collecting the screening data of all the patients, you should design it in an offline architecture mode because she is going from village to village. And some places there is no internet at all. So she can collect all the data, she can perform whatever operation functions she is doing. And at a point of time when connectivity occurs, she should be able to sync entire data back with the server. So that kind of architecture is needed in the mobile. But whenever we are talking about mobile application, we never think of offline scenarios. So these are the design lacunas which need to be addressed in the mobile first strategy. Any questions here? Raghav, Aditi, Akriti?
No, sir. So just that it is on the when we start developing an app for the browser, it is the same time that we should also start for the mobile.
So as you said, the mobile first strategy, it says that you first think the design in terms of mobile because it is a minimalistic design. Okay. You can always expand it to the browser.
Okay, sir.
But so I would say it is the MVB version of the of your design basically.
Okay.
And I think this point we have already covered. So there is nothing much remained here. So one more thing I want to add is yesterday I covered about data anonymization and deduplication thing. So data anonymization, deduplication, encryption, consent mechanism. These are some of the techniques which NDHB recommends. But in that, what NDHB says is that all your records should be collected at a central place and then anonymization should be done. In my opinion, anonymization should be done at the source itself because most of the data leakages happen by the system administrators in the hospitals. So they are not doctors, they are just administrators and they also have the access to the data and nobody can know, what they are doing with the data, whom they are sharing and all. So if you are doing any deduplication or anonymization, it should happen at the source. Rather than collecting all the data at a repository level and then doing it. Then consent, as we discussed, that consent is a big problem in India. Considering that we have the illiterate people do not know the impact of the context of the consent. Somebody will say that, okay, sign here. They will not even see what they are being asked to sign for. So when we are saying consent, what would be the consent structure? Would it be explicit always or would it be implicit? Would there be certain scenarios where consent can be waived off? Particularly in the scenario when patient is unconscious and there is no attendant caring with the patient. And you need to immediately refer that patient to another facility and you need a consent to exchange that data. Now patient is not in a position, he's unconscious or he's in a life-threatening situation. So he cannot exchange his data with his consent. So how will you exchange that? So there will be certain scenarios which need the waiving off of the consent. And then, certain consent thing will be time-based. So if you have sent a DICOM file to the payer for adjudication, how much time you want to keep that image file with the payer thing? Because payer has, so unless there is a mandate on the payer not to share this data with, rest of the world, they can do whatever they want. So we should clearly think if we are sharing the data with any other entity, what is the scope of that sharing and how much time period you want to make that data available for him. So it should be time-based. And this time-based, expiry time should be defined for storage, for query, for streaming at all the three levels. So our consent has to have a detailed machine-readable policy document which define all these things. And if there is a waiving off, then what are the additional controls which we can ensure the security of data if patient is not in a position to give his consent? And again, certain things which are the implicit consent, for example, where you think that patient always give the consent, like in the case of payer thing, we can say that, there is always an implicit consent for the clinical document that are shared between provider and the payer for claims, because ultimately, patient want his money back. But again, there can be certain data in that which need to be sensitive and which require a explicit consent also. So if there is a maternity related data or there is a sexual transmission disease related data, it cannot be made explicit to anybody in the payer side. So there has to be the explicit consent. So basically these are the open questions I'm highlighting, and whatever consent policy we have to define, we have to take care of all these borderline cases, corner cases as well. Then other thing is, we are talking about repository providers and we are talking about data fiduciaries, but then they should be made very clearly responsible for any data security breach, because provider side, it is very difficult to implement all the controls related to, data security, consent and everything. Ultimately, all the data will come at the, repository level, and these are the custodian of data. So they should be legally held responsible if there is any breach. And one more thing is, we are talking about PHR. So again, in PHR, patient should be in a way to link or delink some of his records from his PHR. So if, let us say, a hospital is sending all the clinical documents or links to those documents, the patient doesn't want to share some of his, disease related thing to the other providers because of whatever reason, then he should be in that control. So he should be able to decide, I want to only share this much data in my personal record. And last point I want to say is, this security, when we are talking about security, so I have already said it should be at the level 3 and 4 minimum. So any questions here? And this is the last slide of this current session. This is the approach which NDHB is talking about, minimalistic and scale fast approach. So one of the point I've already covered that they clearly mean that application should be auto scalable. And auto scalable, the COVID example I already gave, like once a day, if suddenly there is a surge in the demand of the clinical services, your system should be able to cope up with that. So that kind of auto scaling feature, you should not make a downtime, then increase a virtual machine, and then kind of ramp up your server. It should be auto in an automatic manner. And if you have to do that, then you have to follow certain common things, like you need to follow the cloud patterns which we discussed earlier. You need to have an automated DevOps. Then you need to have a container-based deployment, Docker and the Kubernetes, which we are teaching to all of our SCA members. And then we need to externalize our configurations. And this is irrespective of microservice architecture. Even if somebody doesn't want to use microservice architecture, these are the basic cloud patterns which need to be implemented. And then one more thing is, whatever application design is there, it should be decoupled design. So for example, if there is some problem in one particular module, it should not stop the entire application. So there should be a minimal dependency among the modules. And the read and write should be separate. Now this is a very contentious point in terms like architecturally it is required that you should have the separate read and write, because 70% of your load is because of read operations. People are reading the data. Doctors are reading, patients are reading, and writing is only 30% of your total load. But all the read and write operations are happening in the same database. So because of the 70% read load, your 30% write operations are impacted. This is the current scenario. You may not kind of assess the impact of this if you have a small community of users accessing it and your user size is small. You will face the impact when you have a national level deployment. For example, Dr. Lal Lab. Now, Dr. Lal Lab, you are getting the samples across the country, and your volume of load processing is very high, and a lot of samples are coming, getting processed. At the same time, a lot of report readings are happening. So patients are accessing their reports, and the radiologist, the lab technicians, they are writing the reports, they are reading the reports. So a lot of things are happening the whole day. So at the national scale, if you're deploying your application, then read and write load, impact too much. And database is a single point of failure in the entire architecture. You may control the performance at the application server easily, at the web server level easily, but data server level, maintaining the load is very difficult. So at the microservice level, we recommend, a particular pattern, which is CQRS pattern. It's a command query responsibility segregation pattern, which we will talk about in the microservice class. But again, it's a very complex architecture, I would say very frankly. And one of the reasons, why people are reluctant using microservices because of this CQRS pattern. So then we have to think of the easy solutions as well. So basically what we want is, we want to separate the read load and the write load. So assuming that you have one database and you are setting up the replication between two database nodes. So one of database is active database, the other database is passive. So like in our Max Healthcare, we set up two environments, two databases basically. So one was the active database on which all the operations were happening. The other was the passive instance, which was just a standby. And you can create as many passive instances. Now, passive instances, you cannot write directly. You can only read from that. So what happens is, if we have a kind of strategy where we can separate our read and write at the data source level, at the data source connection level in the application logic, so that if I'm kind of writing something in the database, then it hit my main database. But if I'm reading something, it should read from the replicated node. If we can implement this kind of strategy, then we don't need a complex architecture like CQRS. And this is quite possible because I think Ved Prakash can know it very well that, in the same application, we can create as many connection providers, data source connection providers in Spring Boot. So basically, we should also recommend this kind of alternate design to our SCA community if they are not happy implementing CQRS. And then we have, several databases which have the inbuilt features to manage this feature. Like for example, if someone is using Oracle, then Oracle has a Golden Gate, feature. And Golden Gate by design provide the flexibility of separating my read and writes. So this is another way, like we can tell the people that, okay, use Oracle. If somebody has a large scale deployment, and they can follow this kind of feature. So what I'm trying to put on the table is, as an analyst team, as a team, we should think of all the possible alternatives rather than sticking to one single thing. We are not evangelists of a particular technology. So we are kind of guiding the people and mentoring them on all sort of alternatives available in terms of design. But yes, these are, minimum things that are required to ensure the minimalistic and skill fast approach. So that's all for the today's session. If any questions, please raise the queries. Raghav, Adit. So I will share this slide deck with you, Raghav, with the team.
Yeah. Yes, sir. Thank you.
Yes, sir. Thank you so much.
Thank you, Krishan.
Thank you, everybody.